it's Fernanda again. Welcome back to GED On. On today's video, we will be covering part 1 of chapter 4, Data, Statistics, and Probability. Now, this chapter is fairly long, so we felt it was best to split it into part 1 and part 2. Therefore, there will be 2 videos. It's very important that you remember to watch part 2 of this chapter after finishing today's video. As you already know, you are more than welcome to pause and replay this video at any time, especially if you need a little bit more time to review the material. Now that we have introduced our chapter, let's go ahead and get started with our first lesson. Like always, we will be utilizing the Kaplan GED Test Prep Plus book for this and all GED On platforms. You can find a link below in the description box on where to purchase this book at your local store or online. On today's video, we're going to cover Unit 2, Mathematical Reasoning, Chapter 4, Data, Statistics, and Probability, Part 1. We will be covering lessons 1 through 4, which start on page 280. Now, Chapter 4 is pretty long, so it will be split into 2 parts. Therefore, it's really important that you watch Part 2 after finishing this video. Now, let's go ahead and get started. Let's start with our first lesson, Lesson 1. Tables and pictographs. Alrighty, let's start our first lesson. Lesson 1, Tables and Pictographs. So as you may have discerned from the title of this chapter, we are going to be speaking quite a bit about data. Data is composed of facts and information. By analyzing data, we can do all kinds of things, such as making predictions, drawing conclusions, and solving problems. One way to organize data is by using a table. A table helps organize data in columns and rows, with the assistance of appropriate labels, of course, so that the information can be easier to process and understood. Here's a few examples of different tables representing different sets of information. Tables tend to be used often when it comes to presenting information on public platforms such as articles, TV, and videos, just because they're very easy to understand and kind of just take in the information visually. Let's take a look at our first example table and try to solve the problem based on the information that we are provided. Example 1. The table below shows population figures for selected counties in 2000 and 2010, and the land area in square miles for each county. Which county showed the greatest percent of increase in population from 2000 to 2010? So let's start with step 1 of our tables and read the labels. So you can see that each column or vertical line of information is labeled. We have county, 2000 population, 2012 population, and land area in square feet and miles. However, for the purpose of the question we are trying to answer, we don't need the last column relating to square miles. Step 2, analyze the data. So if we look at our counties from left to right and compare their 2000 and 2010 population, we can see some immediate differences. We see that only Adams and Davies counties increased in population, while the others decreased. This helps us narrow down the data which is actually necessary for the problem. This leads us to step 3, use the data. So our question is not asking us to determine which counties grew in population, but is asking us about the greatest percent increase. To find this, we have to find the percent increase individually for both Adams and Davies. Then we can compare both of those percentages to determine the largest increase. So let's go ahead and start out with Adams County. So we can see that in 2010, Adams County had a population of 15,295, while in 2000, it had a population of 11,128. Now, in order for us to find the percentage, we're going to go ahead and subtract the 2000 population from the 2010 population and place it over the denominator of the 2000 population. This gives us a decimal of about 0.374, which then, of course, gives us about 37%. Now let's look at Davies County. In 2010, Davies County had a population of 90,834. In 2000, it had a population of 82,204. We're going to do the exact same thing as we did with Adams County. So we're going to subtract the 2000 population from the 2010 population over the denominator of the 2000 population. This gives us a rough decimal of about 0.105, which as a percentage is about 10-11%. Now, if we compare 37% to 10%, we can see that Adams County had the largest or greatest percent of increase in population from 2000 to 2010. Let's go ahead and look at another example. Example 2. A city has 3 public library branches. A librarian kept track of the numbers of books checked out from each branch in a week. He used the data to create the pictograph below. From March 4th to March 10th, how many books were checked out from the South and West branches combined? So this table may look a little bit different than before as it doesn't actually utilize digits. It's called a pictograph because it's using pictures or images to represent a set of data. Now, we know that it's representing a set of data as we have a key picture to the right of the actual table. So this key lets us know that each of these book pictures represents 150 books, not a single book. From this, we can also determine that pictures in which only half a book are represented also then represent half of 150 books, which would be 75. So like before, let's go ahead and break down this particular problem into steps. So we want to determine the amounts of each branch. So if we're just looking at South and West branches, we can see that at South, we have 1, 2, 3, 4, 4.5 books. Again, each of those either representing 150 books or 75. While at West, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 books, each representing 150 books. Now, because this particular problem is asking us to find the amount of South and West branches combined, that's what we're going to go ahead and do. So, in order to take pictographs and to turn it into data, we're going to go ahead and use this first to determine how many books we have for each. So let's just count the book images as just a single book. Let's kind of put that 150 books key to the side. So at South, I mentioned that we have 4.5 books, and at West, we have 9. So we're going to go ahead and combine these. So in this particular case, we're only going to add the whole numbers, 4 and 9, which gives us 13. We're then going to carry over that fraction of 1/2. So in total, we have 13.5 symbols. Okay, so remember these are just the symbols or the images of those books but not the amount that is actually determined. So in order to find out how many books there are total, this is where we're going to kind of bring back that key of each of those book images representing 150 books. So we're actually going to multiply 13 and 1/2 times 150. However, in order to make it a little bit easier, we're going to take that fraction and turn it into a decimal. So as you know, 1/2 or 1/2 represents the decimal 0.5. So this was just a quick transition, and it'll make it easier on your end, whether you're using a calculator or actually working this out on your own. So if we take 13.5 times 150, that gives us a total of 2,025 books. So the 2,025 books is the combined amount of the books that can be found at both South and West branches. Therefore, this is our final answer. Now that we have finished Lesson 1, let's go ahead and move on to Practice 1, found on page 281. At this time, go ahead and pause the video and use the table found on page 280 to answer question 1. Once you have solved this on your own, go ahead and click play so that we can work through it together. Alrighty, practice 1, question 1. On average, how many people were there per square mile in Bell County in 2010? So you might recognize this table from our previous lesson at the very beginning, but this is asking us to find something a little bit different. So it's basically saying how many of these people fit in each of these square miles. Okay, so this lets us know that we are going to be dividing in order to solve this problem. So it's asking us in particular to look at Bell County in 2010. So if we go across our labels, if we start at the very left and look for Bell County, and then move towards the right to the population of 2010, we can see that the population at that time was 22,707. If we keep moving further to the right, we can see that the land area in square miles for Bell County was 2,523. So these are the two sets of data that we're going to use to solve this problem. So, again, the population is 22,707. We are going to divide that amount by the amount of area that's actually available for those people to live in. So we're going to divide that by our 2,523 square miles of Bell County. This gives us a final answer of 9 people per square mile. You could follow the same steps for all of the other counties if you wanted to find the same kind of information. Now, let's go ahead and move on to our next question. Okay, everyone, you know the process. Go ahead and click on pause. Use the pictograph on page 280 to answer question 3. Once you have solved this problem on your own, go ahead and click play so that we can review it together. Okay, question 3. How many more books were checked out from the North Branch than South Branch during the week of March 4th? So you can see that we're using the same pictograph as we were using before. However, instead of finding a combined amount, in this particular question, they're asking us to find the difference. So instead of adding, we are going to subtract. So we can see that the North Branch has, 1, 2, 3, 4, 5, 6, 6.5 books. So remember, this is a key, but we're just looking at the images. While the South Branch has 1, 2, 3, 4, 4.5. So the question is asking us how many more books were checked out from North than the south branch. So that means that we are going to subtract the amount of the south branch from the north branch. So let's go ahead and get started. So as we determined, the north branch has 6.5 books or images, while the south branch has 4.5. Therefore, we're going to go ahead and do 6.5 minus 4.5. Like before, you can technically turn the 1/2 into a decimal if that makes it a little bit easier. But in this particular case, because we are subtracting 1/2 from 1/2, it's actually just going to zero out. So even if you were to do the fraction of 1/2 minus 1/2, you would still get 0. And if you did the decimal of 0.5 minus 0.5, you would get 0. So it's up to you whether you would like to keep the fraction or the decimal. However, we are just going to subtract across the board. So because the 1/2s kind of zero themselves out, and 6 minus 4 equals 2, we can determine that the difference is 2. However, remember that this is 2 of those book images, but it's not an actual amount as we have to use the key. Each book image represents 150 books. So like before, we're going to use our subtraction problem, our multiplication problem to multiply our answer of 2 that we received from right here times 150, which is our key. So if we multiply those, that gives us a total of 300 books. So that means that at the north branch, 300 books were checked out, or 300 more books were checked out than at the south branch. Therefore, this is our final answer. At this time, go ahead and pause the video once again and complete the remaining questions for Section A and Section B. Once you've completed those on your own, go ahead and click play when you're ready to continue. Moving on to Lesson 2, Bar and Line Graphs. Alright, so now we're moving on to bar and line graphs. A bar graph uses bars to represent value amounts. Who would have thought, right? So bar graphs have 2 axis lines. One axis line represents a number scale, and the other axis line shows labels for the bars. Therefore, comparing the length of a bar to the represented scale, you can estimate what value each bar represents. So when we talk about axis, we're talking about 2 different lines. We have a vertical axis and a horizontal axis. Let's look at an example so you can see that a little bit clearer. Okay, example 1. A national corporation made a bar graph, shown below, to show the number of discrimination complaints made by employees during a 6-year period. About how many more complaints were made in 2010 than in 2009? So we can see from our bar graph, we have 2 different axes. The horizontal axis gives us our years that we're going to be looking at. So it ranges from 2006 to 2011. While the vertical axis, or the scale, is going to be represented by the number of complaints. You'll also notice that it moves or it increases in 5-digit increments. So those are going to be our 2 axes that we're going to be looking at. Therefore, the bars that are in the middle of them represent how many complaints you have per each of the designated years. So let's follow our simple steps that we have used in the past in order to solve this problem. So we have step 1, read the labels, which is what we just did. We have step 2, which is analyze the data. So in this particular case, the data that we're going to analyze is the number of complaints made in the year 2010 and in the year 2009. For this particular example, the rest of this data that's represented in this particular bar graph is irrelevant. And finally, step 3, utilize the data. So we're going to utilize the information that we find for 2009 and 2010 in order to solve this problem. So let's look at 2009 first. So for the year 2009, if we move all the way to the top of that particular bar, we can see that there was 20 complaints made in that particular year. Now let's look at 2010. If we go all the way up to the top of the bar graph, we can see that it lands somewhere in the middle between 30 to 35 complaints. Now from here, we can see that it's not quite in the middle, so it's not half. There's no halfway point here, but it's a little bit below. So that gives us about 32 complaints. If it was right at the middle point between 30 and 35, it would be 32.5. But in this particular case, we can see it's about 32. So it's asking us how many more complaints were made in 2010 than in 2009. So this to me sounds like a subtraction problem. So we're going to go ahead and subtract the number of complaints from 2009 from those that are listed for 2010. So if we take 32 complaints for 2010 minus 20 complaints for 2009, that gives us a final answer of 12 complaints. Therefore, there were 12 more complaints made in 2010 than in 2009. Okay, let's go ahead and look at another example. This one is going to look a little bit different, as while it is a bar graph, it's a double bar graph. So example 2. A studio released 4 films in 1 year. The graph below compares the cost of making each movie to its box office receipts, or ticket sales. Film B's cost is what percent of its box office receipts? So again, let's follow our designated steps. We have step 1, read the labels. In this particular graph, the horizontal axis, or the x-axis, has dollars in millions, so that's going to be our scale. While the y-axis has all of the different films listed from film A to film D. Step 2, analyze the data. In this case, the double bar graph really works because the scale is the same. So regardless of the fact that we are both looking at box office receipts and cost, those are both measured by dollars in a million. Therefore, we can list them together in one single bar graph. And finally, step 3, utilize the data. So let's go ahead and use this data to look at film B. So we can see from film B that it has both the box office receipts and cost. So if we look at cost, which is going to be the dark bar, we can see that the cost to actually make the movie was about 30 million. Now, the box office receipts is somewhere between 60 to 80 million. If it was halfway between, we could estimate that it was about 70 million, but it's not. So really, it's about 65 million in receipts. Therefore, this movie cost $30 million to make, and it brought in $65 million of revenue. Because the question is asking us what percent of its box office receipts are the cost, that means that we have a division problem. So essentially, we want to see 30 million divided by 65 million. Again, remember that fractions can turn into decimals, that could turn into percentages, so it's one way across, but we're going to do this by doing a division problem as it is the easiest. So if we divide 30 million by 65 million, that gives us about 0.462. If we want to go ahead and turn that into a percentage, that actually gives us a final percentage of 46%. So that makes actually a lot of sense, because if we have 30 and 65 million, we know that it's going to be somewhere around 50%, right? Because if we have 30 million to 60 million, our answer would absolutely be 50%. But because we have 65 instead of 60, we know it's going to be a little bit less. So 46% is going to be our final answer. Let's go ahead and move on to practice 2.1, found on page 283. Go ahead and pause the video. Using the bar graph entitled Employee Discrimination Complaints, found on page 282, go ahead and solve for question 1. Once you have solved this on your own, click play so that we can review it together. Okay, let's go ahead and start with our first question. To the nearest 10, how many employee discrimination complaints were there in 2006 and 2007? So you might recognize this bar graph from our previous example. So because there's asking us how many employee discrimination complaints were there in 2006 and 2007, this sounds like an addition problem. So let's go ahead and look at both of those years. So if we start with 2006, looking at our bar graph, we can see that there were about 22 complaints made in that particular year. Again, if the bar graph went directly in the middle between 20 and 25, it would be 22.5. But it's not. It's just a little bit below the middle point, so we can estimate that that means it's 22. For 2007, we have about 27 complaints. The same goes for where the particular bar graph aligns, so it falls somewhere between 25 to 30. So 27 is going to be our rough estimate. Either way, the question is asking us to find the answer to the nearest 10, so it doesn't have to be exact. So now let's go ahead and add these together. So if we add 22 complaints plus 27 complaints, that gives us a total of 49 complaints. Now we're going to want to round to the nearest 10. Because this answer is 49, the closest 10th to round it to would actually be 50. So our final answer is going to be 50 complaints. Alrighty, same process as before. Pause the video and use the bar graph entitled Profit Analysis of 4 Films, found on page 282, to solve for question 3. Once you've solved this on your own, go ahead and click play. Alrighty, next question, question 4. About how much more did it cost to make film A than film D? So in this particular case, we're only going to be looking at 2 films, and we're only going to be looking at 1 bar of the 2 that are presented. So you can see that the light gray bar represents box office receipts, and the black bar represents cost. So we are only going to be looking at the black bar for both films. It's asking us how much more, which indicates to us that this is a subtraction problem. So let's go ahead and look at our data. If we look at film A and the black bar, we can see that the cost itself was around 85 million. So it cost 85 million to make this particular movie. Let's look at the same information for film D. If we look at the black bar for film D, we can see that it lands around 65 million. So again, it cost 65 million to make this movie. Because this is a subtraction problem and it's asking us how much more A did than D, we're going to subtract D from A. So if we subtract 65 million from 85 million, that gives us a final answer of $20 million. Therefore, it costs $20 million more to make film A than it did to make film D. Let's move on to the second half of this lesson and look further into line graphs. So a line graph is utilized to show changes over a period of time. It makes it very easy to see increases or decreases across a set of data. By analyzing the rise or fall of the line, you can visually see the increase, decrease, or stagnancy of the data itself. Similar to a bar graph, a line graph also has two axes, which represent two sets of information. So let's look at this in our first example, example 3. The graph below shows the number of patients who visited an emergency room for the treatment of scooter-related injuries. In which month did the greatest increase in scooter-related injuries occur? So we can see our line graph here is of West Side Hospital. Our horizontal axis, or the x-axis, has all of the months listed in calendar order from May to November. Our vertical axis, or y-axis, represents the number of ER visits. You can see that it also increases in increments of 20, so of 20 visits to the ER. So we can see that this particular line graph has a variety of different points. However, in order to determine where we see the greatest increase in scooter-related injuries, we have to see where the line has more of an incline from left to right. So we can see from this particular example that the top point, or the highest amount of ER visits, is going to be somewhere in September. However, it's not asking us for the biggest amount or the largest amount or the most amount of ER visits. It's asking us in which month did we see the greatest increase. So we want to go ahead and look for the steepest line. We can see from this particular line graph that the steepest line, or the steep amount, is most seen between the months of July to August. Therefore, July to August is going to be our final answer. While you can see that the scooter-related injuries did increase between May to September, they weren't all increases of the same amount, and the steepest line overall across the line graph is still from July to August. Okay, next example, example 4. The graph below shows the changes in ticket prices for 2 amusement parks. What was the last year in which admission prices to Park B was greater than the admission price to Park A? If we look at this line graph, this is a double line graph. However, we can have 2 sets of information on this line graph, as the scales that they utilize will be the same. We can see from our horizontal, or x-axis, that it lists calendar years between 2005 to 2010. The vertical, or y-axis, represents ticket price in increments of $10. From our key, we can also see that Park A is represented by a solid line, while Park B is represented by a dotted line. So the question is asking us is, when was the last time the Park B prices were greater than those of Park A? So we can see that this happened in 3 particular years, or 3 particular points on this graph. In 2005, Park B was greater than Park A. 2006, Park B was greater than Park A. And lastly, 2007, Park B prices were greater than those of Park A. So it's asking us what the last year was in which that took place. If we look across from left to right of our line graph, we can see that after 2007, the prices of Park A were higher than those of Park B. Therefore, the last year in which the ticket prices for Park B were greater than Park A was 2007, which is our final answer. We are now moving on to practice 2.2, found on page 285. Using the bar graph entitled West Side Hospital, found on page 284, go ahead and solve for question 1. Pause the video to solve this question, and when you are ready to review it together, go ahead and click play. Okay, question 1. In which month did the number of scooter-related injuries decrease? So you can see that this is the same line graph as before, and we determined that between the months of May through September, the scooter-related injuries actually increased, and we can see that from the slope of the line. So it goes from the bottom all the way to the top. But in this question, it's asking us when it actually decreased. So if we look at our very top point of the most scooter-related injuries, which is in the month of September, we can see that there was then a drop in injuries from September to October. We can see that because the slope then goes down. So it goes from the top to the bottom. Therefore, we can determine that the month in which the number of scooter-related injuries decreased is actually in October. Use the bar graph entitled Comparison of Admission Prices, found on page 284. Go ahead and solve for question 4 on your own. When you're ready to review it as a group, go ahead and click play. Alrighty, next question. Question 4. About how much more did it cost to buy a ticket to Park A than a ticket to Park B in 2009? So you can see this is the same line graph or double line graph that we saw earlier. However, in this question, we're only going to be looking at 1 year. So it's asking us how much more. That signifies to me that this is a subtraction problem. So let's go ahead and look at the data that's represented. We can see that in 2009, Park A had a ticket cost of about $39. That's an estimation, as you can see that the dot or the intersect point between 2009 and $40 is not exactly the same. So it's not right in the middle. It's a little bit below. So it's about $39. Now, in 2009, Park B, represented by the dotted line, had a ticket cost of about $29. So we want to determine how much pricier it was to attend Park A than Park B, or the ticket cost. So we're going to subtract those two. So we're going to take $39 minus $29, which gives us a difference and a final answer of $10. So it costs $10 more to buy a ticket to Park A than a ticket to Park B. Alrighty everyone, you know the deal. Go ahead and pause the video, complete the remaining questions for section A and those for B. Once you have solved for those, go ahead and click play so we can move on to the next lesson. We are now moving on to lesson 3, circle graphs. Alrighty, now that we have looked at bar and line graphs, let's move on to circle graphs. Some people call them pie charts, so in case you're a little confused, they are the same thing. Circle graphs are designed and utilized to demonstrate how a whole is broken down into parts. So similar to a pie chart, or the same thing as a pie chart, you can see the different slices of the entire whole or the entire pie. Sections of circle graphs are often labeled with percentages. So similar to how our line and our bar graphs had their two axes that were also labeled, each section of a circle graph also has labels. Now each section of those is reflective of the size that it actually represents. So let's go ahead and look at an example of this. Example 1. A graph below shows how a children's sports camp spends its weekly budget. How much does the sports camp spend on lunches each week? So if you look to the right of your screen, you'll see our circle graph or our pie chart. So this particular graph is broken down into what appears to be, let's see, 5 sections. The entire pie chart is reflective of how the camp's budget is broken down. So we're going to go ahead and answer this particular question through our series of steps once again. So step 1, read the labels. So our labels are permits, umpires, lunches, equipment, and bus. For this particular example, we're really just going to be focusing on the section labeled lunches, the 35%. Step 2, analyze the data. So this particular question is asking us to find how much 35% is of the overall budget of $2,250. Step 3, utilize data. So let's go ahead and solve for this particular problem. So we know that the overall camp budget is $2,250. This budget has to cover everything that is listed in the circle graph, including the permits, umpires, lunches, equipment, and bus. We know that the lunch section takes up about 35% of the overall budget. Now, looking at our graph, we can see that the lunches or the expenses of the lunches is the largest item on this budget. So it's asking us how much does the sports camp spend on lunches each week? This to me sounds like a division problem. So let's go ahead and do that. Now, technically, you can find what 35% is of 2,250. However, we're going to make it a little bit easier. So instead of division, we're actually going to multiply. So you'll notice that we turned that 35% into a decimal, which is 0.35. So in order to find 35% of 2,250, we're going to go ahead and multiply those together. This gives us an answer of $787.50. That means that 35% of 2,250, which is spent on lunches, is $787.50. Now let's look at example 2. According to the graph, what percent of the average energy bill is spent on drying clothes, lighting, and heating water? So if you look to the right of the screen, we have another circle graph or another pie chart. This one is going to be showing how energy dollars are spent. So similar to our prior example, we're going to go ahead and solve this in those same series of steps. So step 1, read the labels. So these particular labels are heating and air conditioning, water heating, cooking and refrigeration, lighting, other, and clothes drying. Now, if you look at the dollar amount that's listed under each of those labels, you'll notice that it's actually in cent form. But if you were to add up all those together, it's actually equivalent to a single dollar, which is really important that you keep in mind. Step 2, which is exactly what we just did, we're analyzing the data. In this particular example, we are focusing on 3 different sections. We have drying clothes, which it looks like is 0.03 cents, lighting, 0.05 cents, and heating water, which is 0.17 cents. Now finally, step 3, we're going to go ahead and utilize that data. So, because it's asking us for the overall percentage, we just need to know first how much those 3 sections come to together as a sum. So again, we have drying clothes, lighting, and heating water. If we want to go ahead and add those together, that brings us to about 25 cents. Now, this is not the final answer as it's asking us to find the percentage. So remember how I mentioned that the overall sum of these different sections came out to $1? That means that we have 25 cents of $1. So if we want to switch 0.25 to a percentage, we know that that is the same thing as equivalent to 25%. So 25% of the overall energy bill is spent on drying clothes, lighting, and heating water. Now that we have finished lesson 3, we're going to move on to practice 3, found on page 287. At this time, go ahead and pause the video and use the Sports Camp Weekly Budget Circle Graph found on page 286 to solve for question 1. Once you've solved it on your own, click play so that we can review it together. Okay, so let's go ahead and solve our first question. What percent of the total sports camp budget is spent on equipment and umpires? So we have our same circle graph as before, but luckily for this question, it's asking us to find a percentage. And if you can see from our labels, all of these sections already have percentages with them. So this is just going to be a quick addition problem. So here we go. So we know that our weekly budget for this entire camp is $2,250. Now, it's asking us to look at the percentages of equipment and umpires. So we see that in equipment, we have 18%, and umpires, we have 11%. Because it's asking us to find the total percentage, we're actually going to go ahead and add these together. So if we add 18 and 11, we get a total of 29%. So 29% of the total sports camp budget is spent on equipment and umpires. Let's go ahead and move on to our next question. Using the circle graph titled, "Where do your energy dollars go?" answer question 4. Go ahead and pause the video to do this. Once you have completed it, click play to move forward. Okay, question number 4. A family's energy bill is $180. Assuming the family's energy use is typical, how much did the family spend on water heating? Okay, so again, we have our same circle graph. Now we know that the budget is $180, and we're looking specifically at water heating. So if we look at our circle graph, we see that water heating comes out to about 17 cents a dollar. So let's follow our same basic steps. So again, we have our weekly budget and of course, water heating. Now, this is asking us essentially how much of this $180 goes towards water heating. So it'll be similar like the steps that we followed in the past. The first thing that we're going to want to do is convert this 17 cents into something that we can utilize in an actual problem. So we're just going to remove that dollar sign and just turn it into its straight decimal form, which is still 0.17. Now, as we did before, in order to find the amount of something out of something that's already in existence, so 0.17 of $180, we use multiplication. So we're just going to do the exact same thing here. So we're going to take 0.17 times 180, and that's going to give us $30.60. So $30.60 is how much of this family energy bill is going towards water and heating out of the total $180. At this time, go ahead and pause the video to complete the remaining questions for Section A and Section B. Once you've completed those sections, click play when you're ready to continue. We are now moving on to Lesson 4, Measures of Central Tendency. So we're going to go ahead and start our lesson 4 by speaking about frequency tables. A frequency table shows how often an item appears in a data set or a set of data. So let's look at an example of this. I think once you see an image of it, you'll be able to kind of familiarize yourself with having used it in the past. So example 1. The sales manager at Montana Motors asked her sales staff to keep a record of the color of cars that were chosen for test drives in 1 month. Then she combined the data to make the frequency table shown below. What was the ratio of black cars driven to silver cars driven? So the frequency table is going to be what you see on the right. So you'll notice that this frequency table is composed of tally marks. So in case you didn't know, or you might need a little reminder, you will see that the tally marks that have a horizontal, or I guess like a diagonal line across them, means that those are tally marks of 5. So you don't have to count every single individual line. Okay, so if they have a diagonal line going across, that entire section is 5 tally marks. So you can just go ahead and count these in series of 5s. Let's look specifically at black and silver cars. So looking at where it says black cars, let's go ahead and count how many cars are there. So we have 5, 10, 15, 20, 25, 26, 27. So we have 27 black cars. Silver. If we go down to silver, we see 5, 6, 7, 8, 9. So we have 9 silver cars. Now, basically what it's asking us is how many black cars do we have to silver cars that are driven? So it's a comparison of 2 sets of data. Therefore, we're going to go ahead and turn this into what appears to be a fraction. So we have 27 black cars to 9 silver cars. Now, looking at the 27 over 9, we can see that 9 is a multiple of both numbers. Therefore, we can actually reduce this. So if we divide 27 by 9 and 9 by 9, that gives us 3 over 1. Now, if the question was asking for, say, a whole number, we can then take the 3 over 1 and turn it into 3, right? Any whole number over 1 means that the whole number on top is actually the answer. However, this is actually speaking about ratios. So instead of saying that there's 3 over 1 or just 3, we know that this actually means that there is 3 black cars to 1 silver car. Therefore, our final ratio, again, is the ratio of black 3, or 3 black cars, to silver 1, or 1 silver. So it looks like black cars are actually taken out for a test drive a lot more than silver cars. Let's go ahead and keep going. Let's take a look at example 2. The table below shows the ages of the customers at Louise's Diner for a 4-day period. What percent of the customers were from 25 to 40 years old? So this is really similar like our first example, in the sense that we have the tally marks, we have 1, 2, 3, 4, 5 different sets of data, and it's asking us to find the percentage of essentially the entire whole. So in order for us to determine what percent of the customers were between a particular age range, we want to know what the entire amount of customers is based off of this particular table. So if we were to count up all of the tally marks starting from under 18 to then over 55, we get a total of 70 marks. So essentially 70 customers. Now, the next step would be to find how many tally marks are listed between the age range of 25 to 40 years old. So if we count those up, we have, 5, 10, 15, 20, 25, 26, 27, 28. So we have 28 marks, or 28 customers, that are between the ages of 25 to 40. Similar to our previous example, we're going to go ahead and put these in fraction form. So we have 28 marks of 70. If we were to then reduce this particular number, we can reduce it to 4/10. Again, remember that you have to find a multiple that they both have in common. Now, we can then take the 4/10 and then transition that into decimal form. So 4/10 is the same as 0.4. So you'll notice that the 4 is in the 10th section, taking it back to our number line days. Now, the actual question is asking us for the percentage. So we're then going to take 0.4 and turn that into a percentage. This gives us a total of 40%. So 40% of the customers are actually between the ages of 25 to 40. Alrighty, everyone, we're cruising right along. Let's go ahead and move on to practice 4.1, found on page 289. At this time, go ahead and pause the video and use the Montana Motors table found on page 289 to answer question 1. Once you have solved for this question, click play so that we can move on. Okay, our first practice question states, what was the total number of test drives of black and white cars combined? So this is the exact same table that we used before, except that now we're going to be looking at black and white cars instead of black and silver cars. So it's asking us for the total amount. So that means that we are going to add the number of black cars and the number of white cars in order to get our final answer. So if we look at our tally marks, we know that we have 27 black cars and 30 white cars. So if we then go ahead and add 27 plus 30, we get a final answer or a final total of 57 cars combined. That means that there was 57 cars as a total of test drives between black and white cars. That was kind of an easy one, so let's go ahead and move on to our second question. Using the frequency table from Louise's Diner found on page 289, go ahead and solve for question 4. Once you have worked through it on your own, click play so that we can review it together. Okay, question 4. What is the ratio of customers under 18 to those over 55? Again, we're looking at information from Louise's Diner, but this is asking us to do a ratio, or how we previously saw it, a fraction. So let's go ahead and look at our data. If we look at the customers that are under 18, which would be that top line in the chart, we have 6 customers. Now, going all the way to the bottom, we know that we have 8 customers that are over 55 years old. So what are we going to do next? We're going to look at the actual ratio by putting this into a fraction. That gives us 6/8. So again, we have 6 customers under 18 to 8 customers over 55. If we look at this particular fraction, we know that we can further reduce this as they both share a multiple. That multiple being 2. So if we divide both 6 and 8 by 2, this gives us a final answer of 3/4. That means that we have 3 customers that are under 18 to every 4 customers over 55 years old. Go ahead and pause the video, complete the remaining questions for section A and B, and click play when you're ready to continue. Hey there, I just wanted to go ahead and check in. We are now about to come up on 1 hour of covering this chapter. Now, as you know, the videos were originally not meant to exceed an hour, but this chapter is particularly long. So, we still have a little bit left to go. Go ahead and keep pushing through. We're almost there. Imagine if someone asked you how much you spend on groceries in a week. There might be weeks in which you spend quite a bit, while there might be other weeks in which you don't spend that much. However, to answer this in a general form, you may choose to answer by using a budget that might be in the middle of both those two areas, as in between an area of spending quite a bit and an area of spending not so much. So in this particular section, we're going to talk about the mean, median, and mode. The middle value between a set of ranges is called an average, or measure of central tendency. So mean is a synonym of average. So if there is ever a problem on the GED test that asks you to find the mean, they're actually asking you to find the average. The most common type of average, again, is called the mean. So let's look at an example of this. Example 3. In 5 football games, a team scored 14, 21, 3, 20, and 10 points. What is the mean or average score per game? Like always, we're going to go ahead and solve for this through a series of steps. So in order to find the mean or average of a set of numbers, we're going to go ahead and follow step 1 by adding the values together. So for this problem, we have 14 plus 21 plus 3 plus 20 plus 10, which gives us a total of 68. Now, for the second half, or step 2, we're going to divide by total number of values or items. That means that we're going to divide this sum of 68 by how many sets of data we were provided, or how many items. We were provided with 5 different score points, okay? So we're going to divide 68 by 5. This gives us a final answer of 13.6 points per game. So that means that on average, in football games, there's 13.6 points that are scored per every game. Let's look at this other example. Example 4. During a 7-hour period, a bookstore recorded the following numbers of sales. Find the median number of sales. So when it asks us to find the median, what it's asking us to do is to find the middle number between the set of data. So that sounds a little funny. So this usually, not always, but usually doesn't require you to really do any kind of math. But at times it may. So let me kind of show you the difference. So there's going to be 2 steps in order to find the median for most cases. We're going to want to go ahead and arrange the values by size. So what that means for this particular example is that we're going to take all of this information, so the 43, 28, 24, 36, 32, 37, and 48, and we're going to arrange those by size. So from smallest number to largest number. Once we have arranged them into the order that we want them, we're going to follow step 2 and find the middle number in that entire set. So here we have the numbers rearranged from smallest to largest. We can see here that we actually have 7 sets of numbers. So from 24 to 48, that's 7 different types of numbers, which makes it pretty easy to find the middle number since it's odd. So in order to find the middle, given that there's 7, we know that there's going to be 3 on one half and 3 on the other half, meaning that the number that's literally in the middle of this entire data is 36. This 36 is actually the median of this entire data set, and therefore our final answer. that previous example was fairly simple because there was an odd number of data points. But what happens when you have an even amount of data points? Let's take a look at this. Example 5. Robert has the following test scores in his math class: 90, 72, 88, 94, 91, and 80. What is the median score? So like before, we're going to go ahead and arrange the values by size and find the middle. But because there is an even amount of numbers in this data set, we have an extra step, and that is to find the mean or average of the two middle values. Then, of course, step 3, we will then have the median score. So here we have rearranged the numbers from smallest to largest. So if you count them again, we have 1, 2, 3, 4, 5, and 6 different data points. Because this is an even amount of data points, we're actually going to look at the two numbers in the middle. In this case, we have 88 and 90. According to our step 2, we are now going to find the mean of the two middle values. So like before, we're going to add these two numbers together. So 88 plus 90 gives us a total of 178. To find the mean or the average, we're then going to divide the total sum by the total number of digits, or the numbers, or data sets, whatever is easier for you to remember. In this case, it would be by 2, since we only have two numbers, 88 and 90. This gives us a final answer of 89. So 89 is actually the median score of this particular set of data. While the number 89 is not part of the original set of test scores, it is still the median since we took the average of the two middle numbers. We're now moving on to practice 4.2, found on page 291. At this time, go ahead and pause the video and follow these instructions. For each data set, find the mean, median, and mode. Round calculations to the nearest hundredth or cent. You may use a calculator. Once you've solved for questions 1 and 2, go ahead and click play so that we can review them together. All right, let's go ahead and get started. For both question 1 and 2, we are to find the mean or average, median, and mode. So let's go ahead and follow that order. Number 1, we have golf scores for 7 rounds. The scores are 76, 82, 75, 87, 80, 82, and 79. So let's work on finding the mean first. So, just to make it a little bit easier for us later, let's go ahead and arrange our numbers from smallest to largest. You don't necessarily have to do this to find the mean or the average, but we will need it for the median. So might as well knock it out now. So if we're looking to find the average or the mean, we're going to go ahead and add up our entire 7 rounds of scores, which gives us a total of 561. We are then going to divide it by the total amount of scores that we were provided. Given that there were 7 rounds, we were provided with 7 scores. So to find the average, we divide 561 by 7, giving us a final answer of 80.14. That's the average score for this game. Now, let's move on to the median. So if we look at our particular data set, we know that we have an odd number of scores. We have 7, which is going to make it quite easy to find the median. If we divide up the 7, we see that the score of 80 is right in the middle. So that gives us a final answer of 80 as our median. Now, our mode. The mode is not something we have talked about quite yet, but the mode of a set of data is going to be the number that appears the most, or in multiple form, I guess you could say that. So if we look at this particular set of data scores, or golf scores, we can see that the score of 82 is shown twice. If you look at the remaining scores, only this number appears more than once. That means that this number, or this score of 82, is our mode. Let's do the same for question 2. Sales totals for 6 weeks are 5,624, 10,380, 8,102, 6,484, 12,008, and 8,315. Let's rearrange our data from smallest to largest, as we're going to have to do that later anyways. So in order to find the mean and average, we are going to add up this entire range of sales totals and then divide it by the number of sales totals we provided. We were provided sales totals for 6 weeks. That means that we have 6 different sales totals. So if we were to add up all of the sales totals, we have 50,923. We are then going to divide that by 6, which gives us a final answer of $8,487.17. That is our average. Now, we were provided an even amount of sales totals with 6, which means that we're going to have to take that extra step in order to find the median. So we're going to take our 2 middle numbers and find their average, or their mean. So if we add those 2 numbers together, we get a total of 16,417. We're then going to divide it by 2, since we're only looking at those 2 sets of data. This gives us a median, or an average, of $8,208.50. Therefore, that's our median. Now, just visually looking at the sales totals, we can see that they're all different. There's not one sales total that is repeated more than once. So that means that this answer for the mode is none, since we do not have a particular sales total that's repeated. Alrighty everyone, you know what to do. Go ahead and pause the video, complete the remaining questions for section A and B, and click play when you're ready to move on to lesson 5. Alright everyone, we made it through part 1. Up next, we will be covering Unit 4, Mathematical Reasoning. Chapter 4, Data, Statistics, and Probability. Part 2.